Hi there, this is Topic 1, Class 1 for fs3128. If anybody else is watching that, you're welcome to watch it. The course is designed as a foundation course primarily for engineers, but you're welcome to watch. Before we get underway with maths properly, we need to start looking at some of the words because we all have to talk the same language. First up, we need to look at what arithmetic is. Arithmetic is really just the study of numbers and how we manipulate them. We can categorize numbers. We can break whole numbers into negative numbers. So we might be coming up -4, -3, -2, -1. Obviously, they go down to negative infinity. And we can talk about positive numbers, which would be 1, 2, 3, 4, and so on. When we talk about addition, we need to know that also what we're really talking about is that we're talking about the sum of two numbers. And when we talk about subtraction, we talk about the difference between two numbers. When we look at addition, one of the things that we notice about addition is that it's what's called commutative. Which means that this is the same as saying that 3 plus 4 is the same as 4 plus 3. If we look at subtraction, clearly that is non-commutative. In other words, 4 minus 3 is not the same as 3 minus 4. When we talk about multiplication, another word for that is we talk about the product of two or more numbers or expressions. And when we talk about division, we talk about the quotient of two numbers. Now, when we talk about a quotient, we are looking really at a fraction, but more on that later. But we talk about the numerator and the denominator. Multiplication is commutative. So 3 times 4 is the same as 4 times 3. But let's have a look at division. Is 4, well, no, let's take a bigger number. Is 8 divided by 4 the same as 4 divided by 8? No. So division is non-commutative. Sometimes we need to compare the size of a number. We want to compare positive numbers with negative numbers, and we might need to add or subtract them. And so sometimes it's helpful to position them on a number line. And here we've got the positive numbers out to the right, purely by convention, and we've got the negative numbers out to the left. And if you look at it, it continues on. It obviously doesn't just stop at 10, but it goes on forever out that way and forever in the negative direction. We can use a number line to add if we want to. So suppose we want to say 5 plus 3. So we start at 5 and we're going to go 3 places to the right. 1, 2, 3. And we end up at 8. So to add a positive number, we move that many places to the right. If we're going to subtract a positive number, then we go the opposite. We move that number of places to the left. So if we're going to say 5 minus 7, so we're going to start at 5, then we're going to go 1, 2, 3, 4, 5, 6, 7, and we're going to end up at -2. Similarly, if we're going to do -3 minus 4, we would start at -3, 1, 2, 3, 4, and we'd end at -7. Then things can get a bit messy. This time we're adding a negative number. And in actual fact, that's the same as subtracting. We move to the left, so it's the same as subtraction. So if we want to say 2 plus -3, then we're going to go 2, 1, 2, 3 to the left, and we get -1. Subtracting a negative number, though, is actually the same as adding a positive number. So if we have 5 minus -3, we start at 5, we're going to move to the right 1, 2, 3 places. We can also use a number line to talk about the part of the number line where our answer might be. Now, if we want to say that our answer might be between -3 and 4 and includes 4 and includes -3, then we can draw it on the number line with a coloured in space, a coloured in circle there, and a coloured in circle there, and then we join those to say that actually our answer could be anywhere between -3 and 4 and including -3 or -4, and we would write that in interval notation, and we would use square brackets to say that we were going to include -3 and square brackets to say that we would include 4. So this is interval notation. If we didn't want to include an endpoint, say if we didn't want to include 1, and if we didn't want to include 4, then we use an open circle. So in the second example here, we don't want to include 1, and we don't want to include 4, so they're left open, and we talk about that using interval notation. We use round brackets, and we write it like that. So again, it's interval notation, but it shows us in the second example that we don't include 1 and we don't include 4. To summarize then, adding a negative number is the same as subtracting a positive number. And subtracting a negative number is the same as adding a positive number. There are rules for multiplying positive and negative numbers. Multiplying and dividing are kind of the same thing, so we'll treat them as the same here. So if we multiply a positive number by a positive number, the answer is going to be a positive number. If we multiply a positive number by a negative number, the answer is going to be a negative number. Conversely, if we multiply a negative number by a positive number, the answer is going to be negative. And if we multiply or divide a negative number by a negative number, then our answer is going to be positive. One of the things about maths is that it's consistent, and it's consistent because we have a set of rules that there are no exceptions for. So when we're evaluating an expression, the way that we do them has got to be the same that everybody in every other country does them, because it cannot be that we get different answers. And if there were no rules, then for this example here, we might say, let's first add 3 to 2 and then multiply the answer by 4. Or we might do 3 times 4 first and then add 2. So we need to know which one it is that we're talking about. And this is where you may have heard of it. Sometimes you see it as BODMAS. Sometimes you might see it as BEDMAS. You might see it as variations on that, but they all tell us to do the same thing. They tell us to do brackets first, then the O is for order, which is the same as exponents. Then we can do division, then multiplication. And the last thing we do is addition or subtraction. Now we do it in that order if we've got a mix match. If we've got lots of operators, lots of pluses and minuses and times and divides, then we do it BODMAS. But if there's only, say, division and multiplication, then we work left to right. If we've only got pluses and minuses, then again we work left to right. So we use BODMAS or BEDMAS or whatever acronym you use if we've got lots and lots of different operations, but if we've just got two and they are at the same level, so divide and multiply or add and subtract, then we work left to right. Now we're looking at different types of numbers. We can look at numbers, we can break them down into factors. So a factor or factors are just the numbers that you multiply by to get a number. So numbers you can multiply together to get another number. For example, if we look at 18, 18 is going to be 6 times 3, or 18 times 1, or 2 times 9, 2 and 9, or 18 and 1, or 6 and 3 are factors of 18. So all of the factors of 18 are 6, 3, 18, 1, and 2, 9. Prime numbers are very special numbers. If a natural number's only got two factors, which are itself and 1, then the number is called a prime number. Now 1 is not actually a prime number because there is no other number that it's a factor that has a factor. So the first 6 prime numbers are 2, 3, 5, 7, 11, and 13, and you can go on after that. But those are the first 6 prime numbers. 2 is the first prime number. Later on in maths, I think you'll see the reason for doing this, but it is useful to be able to write out the factors of a number that are prime. So we take the number, we work out its factors, and we go on working out the factors until we run out, so that all of the factors that are left are just simply prime numbers. So let's start partway into this. Let's say that 720 is 2 times 3 times 4 times 5 times 6. Now we can also see that 2 times 3, well, 4 is not a prime number. We can rewrite that as 2 times 2 times 5 times, and 6 is not a prime number. We can write that as 2 times 3. Now all I'm going to do here is I'm just going to reorder things. I'm going to write 2 times 2 times 2 times 2. So 1, 2, 3, 4, 1, 2, 3, 4, yep. And then I'm going to write times, there are 3 times 3, and then there's 5. So now I have prime factorized 720. And you can do this on the calculator that was specified in the course. You just put in the number. Now it's very important at that stage that you hit the equals button and then you find shift and then the button that's got all the commas on it, because above it it says FACT, and if you hit that it gives you 2 to the 4, 1, 2, 3, 4, and 3 to the no, this is a different question, sorry, 3 to the 4 and times 5. For talking about the highest common factor and the lowest common multiple, we just need to just get it straight in our heads that a factor is what makes up a number and a multiple is something that's being multiplied by. And when we're talking about multiples, we could even talk about pi. We could say pi, we could talk about the multiples of pi. We could say -2 times pi, -1 times pi, 0, pi, 2 pi, etc. So all of those are multiples of pi. And sometimes it's important for us to be able to find the highest common factor, which is the common factor that's the factor that's common to both of the numbers, and it's the biggest of those, or the bigger of those. Or we might also be asked to find the lowest common multiple of two numbers, which is the smallest whole number that's a multiple of both. You can use your calculator to do this. You can use your calculator for two numbers at a time. After that, you have to use other methods, and we'll have a look at that on the next slide. Let's look at finding the highest common factor of 28 and 42. So let's prime factorize 28 for a start. So you can either do it in your head or use your calculator, and we can rewrite 28 as 2 times 2 times 7. Let's do the same for 42. 42 is 6 times 7, which is 2 times 3 times 7. Now, if we look at that, the common factors are 2 and 7. So our highest common factor is going to be 2 times 7, which is 14. For the next question, let's find the lowest common multiple of 11, 17, 21, and 100. This is the lowest common multiple, or the least common multiple. Again, we need to prime factorize them. So if we write out 11 is equal to 11 times 1. 17 is also a prime number. 17 times 1. 21 isn't. We can write that as 3 times 7. And 100 we can write as 4 times 20, so it'd be 2 times 2 times 5 times 5. Now, this is a little trick that works. Let's set up a table. So we've got one line of our prime numbers and the highest number of times they occur. So the prime numbers that we've got are 2, 3, 5, 7, 11, and 17. Now, the highest number of 2's that we've got is 2. The highest number of 3's, we've got one of those. We've got 2 5's. We've got 1 7, 1 11, and 117. So our lowest common multiple is going to be 2 times 2 times 3 times 1 times 5 times 2 times 7 times 1 times 11 times 1 times 17, which is a huge number that you probably have to work out on your calculator. 392,700. Before we can do anything, we need to prime factorize these numbers. So 16 is 2 times 2 times 2 times 2. 24 is 2 times 2 times 2 times 3. 32 is 2 times 2 times 2 times 2 times 2. And 160, 2 times 2 times 2 times 2 times 2 times 5. So if we're going to find the HCF, there'll be those, and there'll be those. So that's 2 times 2 times 2, which is 8. Now to find the LCM, we need to set up our table. And put our primes in, 2, 3, and 5. And the biggest number of 2's is 5. The biggest number of 3's is 1. Same with the 5. So it'll be 2 times 2 times 2 times 2. So that's 1, 2, 3, 4. One more. Times 3 times 5, which is 480.